Okay, so I have my confirmation. Okay, so in this session, we are going to solve a few MCQs on carbohydrate metabolism, and then towards the end of the session, we are primarily going to study about RL shunt, which is a small shunt, but again, a very important shunt. So for anyone who is attending my session for the first time, I'm Dr. Abhishek, your mentor for biochemistry at Unacademy. If you are first time on this Unacademy platform, make sure that you subscribe. If you're seeing this video live for the first time, make sure that you subscribe and hit the bell icon, because not only me, a lot of different educators go live on this platform every month, almost every day, and you'll get a notification whenever we are going live. The main things which we cover is primarily high topics, clinical question, image-based questions, latest trending topics. So these are the things which we cover, and we make sure that even if you're not a part of the Plus platform, you can still get a lot of high important information from here. Okay, and if you have already attended any one of my earlier sessions, I would love if you can give this video a thumbs up, because it will help it to reach to more and more students. So I have been getting this request basically from a lot of students that they want to get notified whenever I go live, and sometimes whenever I take a class, I create those notes and I share it to you, so that you don't have to make notes while you are learning. So this is an email newsletter which with which you can get it. So it's bit.ly. This is the URL shortener with Dr. Abhishek 10. If you go to this, there will be a form. You just fill in that form, and whenever I send a notification, you will be a part of it. So today's topic, will be RL shunt. But before we state about RL shunt, let's look at some of the announcement for the for this session, which Unacademy, from Unacademy end. First is we have enabled this raise a hand feature for all our Plus subscribers. So all our Plus subscribers can actually in real time raise their hand, and if and we can allow them to actually directly speak to us. So that increases a lot of interaction between us and the students in real time. Suppose you have a doubt and you raise a hand, and sometimes just typing those doubts are very very difficult. Okay, you cannot just type those doubts. So you can directly talk us to us during live classes, and that's how you will be able to clear your doubts or understand the topic better, or tell us what exactly you did not understand. These are the two new batches which we have started. They are primarily integrated clinical batches. Okay, and then we have started a high revision batch for NEET PG. We know that NEET PG has been postponed, but now we can see that in next 1 2 months NEET PG will definitely be there. So NEET PG high revision batch is there, where primarily we'll be focusing on all the high concepts of NEET PG, and along with a lot of MCQs which have been asked on those high topics. Okay, is this clear? So this is another very important batch, NEET PG, and this again started. There are two batches for students who are still intern or final year who wants to target exam from next year onwards. There is a target next batch for anyone who is planning to appear for next year. Now target next batch is like from next year it will be not NEET PG, it will be next. There will be some very basic changes in the exam pattern, like there will be more focus on long questions, you know uh, question based questions or something like that. So the idea will be to test more of your clinical knowledge even in your preclinical and paraclinical subjects. Okay, so one liners probably will be very very less, or probably can be completely eliminated from the papers. It will be more of a clinical questions, image based with clinical questions. So where you will be required to put in your applications rather than just knowledge of that particular topic, right? So keeping that in mind, there is a target next batch. Anyone who is a final year intern should definitely go and enroll in this batch. And we had some real good result when it came to FMG. A lot of our students cracked their FMG within first attempt. A lot of our students who were giving FMG for past 2 years but were not able to crack, this year with our FMG batch, they were able to crack it. So there is another focus FMG batch which we have started. So with this announcements, let's start with the first question of today. A 43-year-old man presented with symptoms of weakness, fatigue, shortness of breath, and dizziness. His hemoglobin level was less than 7 gram per deciliter. For normal patient, it will be more than 13.5 gram per deciliter. Red blood cells are isolated from the patient, shows abnormally low level of lactate production. A deficiency of which of the following enzymes would be the most likely cause of this patient's anemia? So your options are pyruvate kinase, phosphofructokinase, hexokinase, and lactate dehydrogenase. So anyone, if you want to, attempt this question. So Charu is saying lactate dehydrogenase. Anyone else? Charu is saying lactate dehydrogenase. Anyone else wants to answer this question? Okay. So here, first important concept is that in RBCs, okay, we are talking about RBCs, okay, in RBCs, only anaerobic glycolysis happens, okay, in RBCs, only anaerobic glycolysis happens. So the significance of this is in RBC, glucose is converted into lactate. It cannot be stopped at the pyruvate level. So this, if you understand that any any metabolic defect in any of the reactions, any metabolic defect in any one of the reaction will lead to lactate formation, decrease in lactate formation. So this is the first concept. It's not just the last reaction, lactodehydrogenase. For example, let's say pyruvate kinase is deficient. Even then the lactate will be. For example, let's say fructose 1,6 biphosphate phosphate, and that is absent. So any reaction in the entire chain will cause decrease in lactate. This is a very, very important concept. Second important concept which I want you to remember is that, remember, number one, what is the most common cause of anemia, metabolic cause of anemia? Or what is the most common enzyme defect which causes anemia? And the correct answer is basically glucose 6 phosphate dehydrogenase. G6PD deficiency is one of the most common cause of hemolytic anemia in patients. Okay, but definitely it is for your hexose monophosphate shunt. Hexose monophosphate shunt. In that case, the lactate level will not be increased. So we are looking at any reaction or any enzyme which is defective in the glycolysis, in the entire glycolysis. Yeah. And remember, the most common is this. The second most common enzyme which is deficient is, remember, pyruvate kinase. Pyruvate kinase is the most common enzyme which is deficient in your glycolysis. Okay, and it is also the second most common cause of hemolytic anemia. Enzyme defect leading to hemolytic anemia. Okay, so both of these will point the answer, although this can also lead to a lactate deficiency, this can also lead to a lactate deficiency, all because all of them are affecting glycolytic pathway. But here the answer is not just based on the low level of lactate, but which enzyme is very, very common in a patient like this. Is this clear, everybody? Good. Hi Ravi, hi Charu, hi med school mnemonics. Let's look at this question. What will happen to TCA cycle during anaerobic, yeah, what will happen to TCA cycle during anaerobic, which means during anaerobic respiration, what will happen to the TCA cycle? Inhibition of electron transport chain, but stimulation of TCA cycle, stimulation of electron transport chain and stimulation of TCA cycle, or inhibition of both of them. What will happen to TCA during anaerobic? So why should electron transport chain? We know that TCA, why should TCA be inhibited, or why should electron transport chain be inhibited when there is no oxygen? If there is no oxygen, why these two cycles should be inhibited? Tell me. Tell me. Why should these be inhibited when there is no TCA? It's a very important, fundamental question. Why can't the TCA continue? Anyone? Why can't the TCA cycle or the electron transport chain continue? Why does, in what step does oxygen is required? No, it's not written that there is no mitochondria. It is simply saying that there is no oxygen, or there is anaerobic respiration which is present, which can happen even in presence of mitochondria. For example, your muscle cells, when they are contracting in an anaerobic condition, anaerobiosis will happen. But why do we need to stop the TCA cycle, or we need to stop the electron transport chain when there is no oxygen? It's not about ATP. The correct answer is, you remember that in electron transport chain, okay, remember who is the final acceptor of the electron? Who is the final acceptor of the electron? Tell me, who is the final acceptor of the electron? The final acceptor of the electron is oxygen. Okay, so if oxygen is not there, this electron transport chain will not work. Yes or no? If oxygen is there, the electron transport chain will not work. If electron transport chain will not work, so all the NADH will not be getting converted back into NAD. Okay, and this what it will lead to? This will lead to a depletion of NAD, because remember, each cycle of Krebs cycle requires 3 molecules of NADH and 1 molecule of AD, and all of them cannot be offloaded if your electron transport chain is not working. So depletion of those, NAD, this will lead to your even stoppage of glycolysis, because we have a deficiency. So ultimately it will get stopped. Stoppage of, TCA, because in the mitochondria there will not be any NAD which is being left. So electron transport chain directly because it requires oxygen, and citric acid cycle or TCA cycle because it requires NAD. If the NAD is not there, citric acid cycle will stop. So the correct answer is yes, you all are correct. The correct answer is inhibition of electron transport chain TCA. But the major reason is this oxygen was required to be the final acceptor of the electron. Okay, very good. Let's answer this question. In glycolysis, the first committed step is catalyzed by. Your options are 2,3-diphosphoglycerate, glucokinase, hexokinase, or phosphofructokinase. So can anyone tell me what is the difference between rate limiting step and what is the difference between rate limiting step and committed step? How does these two differ? How does these two differ? How does a rate limiting step differ from a committed step? Okay. Now, the correct rate limiting step is a very simple concept. In a biochemical cycle, in a biochemical cycle, whichever step is the slowest step, in a biochemical cycle, whichever step is the slowest step, that will become the rate limiting step. Is this clear? Excellent. Very good, Charu. Okay. And very good, Saf also. Committed step means, for example, when glucose is converted to glucose 6-phosphate. Okay, this is the first step of glycolysis. But this glucose 6-phosphate can go into a multiple pathway. It can go into HMP shunt, it can go into uronic acid pathway, it can go into glycogen synthesis, it can go into glycolysis, multiple pathways. So even though it is an irreversible step, but it is not a committed step. But when we talk about fructose 6-phosphate being converted into fructose 1,6-biphosphate with the help of phosphofructokinase. So remember, first of all, committed step has to be a reversible step. It cannot be a irreversible step. But not only it should be a irreversible step, but once this is formed, this will necessarily go into glycolysis. It cannot go into any other pathway. Necessarily go into glycolysis and cannot go into any other metabolic pathway. So all of you are clear what is the difference between a rate limiting step and a committed step. Let's answer this question. Cancer cells derive its nutrition from? Your options are A. Glycolysis, B. Oxidative phosphorylation, C. TCA cycle, or D. Increase in mitochondrial activity. Cancer cells derive, and what is this effect called as? Can anyone write? If you are writing the answer, just put it in the comment. What is this effect called as? Because you won't believe such a simple concept, 2 year back-to-back question has been asked. What is the effect? Now, regulatory step and rate limiting step. Regulatory steps, some reactions like Krebs cycle, they do not have a single step which is the slowest step. There are 3 different reactions. All of them are irreversible, and all of them can increase or decreasing, controlling the entire Krebs cycle. So that is the regulatory step. Sometimes, for example, let's talk about glycolysis. There are 3 steps and none of them is rate limiting. Okay, what are the 3 steps in glycolysis which are critical steps? Okay, the conversion of pyruvate into phosphoenol pyruvate, the conversion of fructose 1,6 biphosphate into fructose 6 phosphate, and glucose 6 phosphate into glucose. All of these, none of these is rate limiting. So there are so many biochemical cycles where you don't have a slow step. There are multiple steps. It's like, when you see this is a road, okay, there's a road, and the road becomes narrow here, and only one place it becomes narrow. So this is the rate limiting step. And when we talk about regulatory step, this is a road. Here you have a police line. Here you have a police line, and here you have a police line, I mean police, that you call hurdle. Okay, so these three becomes regulatory step. Is it clear, all of you? Is this clear, Charu? Now, are you clear about rate limit? So here, cancer cells derive its nutrition from glycolysis. Okay, the correct answer is glycolysis. And what effect we call it? We call it as a Warburg effect. Warburg effect. Okay, and there is another effect which has been asked, that is called as Pasteur effect. What is Pasteur effect? Pasteur effect is that normal cells, all the normal cells, so remember Pasteur cells is in normal cells, all the normal cell will inhibit an aerobic glycolysis. So anaerobic glycolysis will not happen in normal cells whenever oxygen is present. Okay, whenever oxygen. So whenever oxygen is present, no normal cell will go for an anaerobic glycolysis. They will always go for aerobic glycolysis. This is Warburg effect. And what is your, what is your, sorry, this is your Pasteur effect. And what is your Warburg effect? Warburg effect is that even the cancer cells, even when there is a lot of oxygen, it will, utilize the, glucose to get into anaerobic glycolysis. And the reason why this is seen, the reason why this effect is seen is because, these cancer cells, they want to multiply very, very quickly. Okay. And because to multiply quickly, there needs a lot of intermediates of metabolism. Okay, like they need a lot of growth material, and that material, so the glucose is converted into creation of those material, like say heme, or let's say amino acids, non-essential amino, so many things, DNA, RNA. So this glucose is channelized into creation of those rather than channelized in creation of energy. So that is why Warburg effect happens. Is this clear? Normal cells, they do not want a lot of this anabolic material. What they want is a lot of energy to maintain homeostasis. Okay, they want to run the normal functions of the cell, and for that they require the energy. But cancer cells, they are least concerned about homeostasis. They want to multiply, so they need a lot of anabolic intermediates, which can be provided by diverting the you know glycolysis to into these anabolic products. Let's answer this question. Let's answer this question. A 4-month-old boy is brought to the physician because of seizure. He was delivered at term after uncomplicated pregnancy. He is currently the 10th percentile for height and 5th percentile for weight and 15th percentile for head circumference. So there is not much of a growth retardation until the weight is concerned. Examination shows muscle hypotonia. His serum lactate. Now this is a very, very important clue. His serum lactic acid and alanine levels are elevated. Okay. So pyruvate assay of PDH in serum leukocyte shows decrease enzyme activity. Supplementation of which of the following should be avoided in this patient? So Charu is saying D. Saf is also saying D. Both of you are wrong. Okay. So here, obviously, where is the problem? The problem is that this pyruvate is in getting converted into lactate and alanine. Okay. This is the problem. So there is an increase in pyruvate, which is leading to alanine and lactate. So what is the major pathway in which this pyruvate goes? What is the major pathway? So the major pathway for pyruvate in our body is link reaction, by which the pyruvate with the help of PDH is getting converted into acetyl-CoA. And as given as a fact in the question is that this pyruvate dehydrogenase is not active. Okay, so this explains the clinical question. Now we should avoid anything which will increase the pyruvate level. We should avoid anything which will get converted into pyruvate and increase the pyruvate level, which cause then what will happen? This pyruvate cannot go into this pathway, so they will go into either lactate or alanine, and this lactate will further cause harm because it will cause lactic acidosis. So let's look at the options now. So when we look at our first option, arachnoic acid. Now remember, arachnoic acid will not form because it is a fatty acid. It will never be broken down into pyruvate. It will directly form acetyl CoA. So this, in fact, should be given. When we talk about valine, it's a purely glucogenic amino acid. Okay, it's a purely glucogenic amino acid. Now, if it is glucogenic amino acid, it will finally get converted into pyruvate. So this should not be given. When we talk about lysine, lysine again is a purely ketogenic amino acid. Purely ketogenic amino acid, which means lysine will be converted into acetyl CoA directly. So again, this we can give. In fact, this should be preferred. When we talk about thymine, now here we understand that this reaction is slowed down. But when we give a cofactor for any reaction, even if the enzyme is less in quantity, that enzyme will be enhanced because of the cofactor. Cofactor does not decrease the rate of the reaction, they increase the rate of the reaction. So thymine supplementation actually is a must for this patient. Must for this patient. The only thing we should be avoided is valine. No, Pratik, this is not a UG class, this is a PG class. Very good, Ravi. You're correct. PDH, it's a complex, so it will have more than one enzyme. Okay, but thymine is the major, cofactor. Okay, and pyruvate dehydrogenase is the major enzyme. Okay, let's answer this question. Tyrosine enters gluconeogenesis by formation of which of the following substrate? So which substrate tyrosine forms and then enters into gluconeogenesis? I think NEET UG is tougher, Pratik. Okay, let's answer this question. Tyrosine enters gluconeogenesis by formation of which of the following substrate? Your options are succinyl CoA, alpha ketoglutarate, fumarate, and citrate. So Ravi, very, very quick to answer. So remember, there are only two amino acids which will enter at fumarate level. And both these brothers, tyrosine and phenylalanine. Tyrosine and phenylalanine, both these brothers, we know they have almost every reaction same. So these two brothers enters at fumarate. Excellent. Let's answer this question, all of you. Amino acid which can be used both in gluconeogenesis and ketogenesis. Amino acid which can be used both in gluconeogenesis and ketogenesis. Is it threonine? Is it valine? Is it tyrosine? Or is it arginine? So remember, based on the metabolic fate, we classify amino acids as purely glucogenic, purely ketogenic, and both glucogenic plus ketogenic. When we talk about purely ketogenic, there are only two amino acids which are purely ketogenic. We call it lovebirds, lysine and leucine. Why? Because these are the only two amino acids which will never form glucose. Rest all amino acids will either purely be glucogenic or at least glucogenic plus ketogenic. When we talk about this group, we call it as a fit group. F I T T. F stands for phenylalanine because the single letter representation of phenylalanine is F. I is for isoleucine. Okay, you see leucine is here, isoleucine is here. T is for tyrosine. We know because phenylalanine is there, so phenylalanine, tyrosine, everything will be same. And last is tryptophan. Tryptophan. So these fit amino acids are glucogenic. Rest everything is purely glucogenic. So when we see this is purely glucogenic, when we talk about valine, this is purely glucogenic. When we talk about tyrosine, this is both glucogenic as well as ketogenic. And when we talk about arginine, again it is purely glucogenic. So the correct answer is C. Okay, let's answer this question. What is the precursor of proline in Krebs cycle? What is the precursor of proline in Krebs cycle? So what is the answer? What is the precursor of proline? So SAF says D, Med School Mnemonic says D. So both of you are correct. So remember, this is again a very important set of questions. Which amino acid enters at what level? So alpha ketoglutarate level, proline enters. So this brings us to almost end of our theory session, and now we are going to, we are going to go to our theory session for today. Just give me one option. Okay. So we will start with RL shunt. So what is RL shunt or Rappaport Lubring cycle or 2,3 biphosphogylycerate shunt? It has multiple names: 2,3 biphosphogylycerate shunt, RL shunt. And the basic thing is that in RBCs, we remember that in RBCs we require 2,3 biphosphogylycerate. We require 2,3 biphosphogylycerate in RBC. Can anyone tell me why do we require 2,3 biphosphogylycerate in RBCs? Anyone? Can anyone tell me why do we require 2,3 biphosphogylycerate in RBCs? We require 2,3 biphosphogylycerate in RBCs because this is very important to regulate the delivery of oxygen. Okay, delivery of oxygen. Okay, from hemoglobin. So what happens is, if you see, okay, if you see that these RBCs, they carry oxygen. Okay, now this oxygen should not be let out at the same time, immediately. So these oxygens are slowly released, and as this tissue reaches, there are a lot of factors which will ensure that the RBCs release the oxygen they are carrying in a very very phased manner. Not all the oxygen will immediately be, otherwise your peripheral tissue will not get oxygen. So this is one of the mechanisms to ensure that your RBCs keep delivering the oxygen in a phased manner is 2,3 biphosphogylycerate. So as your RBC is moving into the peripheral tissue, it produces more 2,3 biphosphogylycerate, so that 2,3 biphosphogylycerate will displace oxygen and lead to release of oxygen. So that is why, to regulate the release of oxygen in a phased manner, we RBCs require 2,3 biphosphogylycerate. So the first thing you have to remember is this Rappaport Lubring cycle or 2,3 biphosphogylycerate cycle, they operate only in RBCs. In no other organ they will operate. Okay. So what is this? So first, let's look at this reaction. This is basically an overview of glycolysis. So what happens? One step particularly we are going to learn is this glyceraldehyde 3-phosphate is converted into 1,3 biphosphogylycerate. The enzyme is glyceraldehyde 3-phosphate dehydrogenase, and then 1,3 biphosphogylycerate is converted into 3-phosphoglycerate, and 1 ADP is converted into 1 ATP, and the enzyme is phosphoglycerate kinase. So this is a very very simple reaction. This is what is going to happen in your Rappaport Lubring cycle. But imagine when this shunt is in. What is shunt? Shunt is basically an alternate pathway. And in that alternate pathway, what happens? That this 1,3 biphosphogylycerate is mutazed, which means it undergoes isomerization and it forms 2,3 biphosphogylycerate. It forms 2,3 biphosphogylycerate, and this 2,3 biphosphogylycerate again, that loses one phosphate and gets converted into 3-phosphoglycerate. So additional step is added. The prob so this 2,3 biphosphogylycerate is formed, and when the work of 2,3 biphosphogylycerate is over, which means when the RBC is returning back to the lung to get the oxygen, then again this 2,3 biphosphogylycerate is converted into 3-phosphoglycerate. So there is no more 2,3 biphosphogylycerate, and the RBCs can take the oxygen more in a better way. So there are two things. First of all, so this is being formed, but if you see, entire when this shunt is taken, this ADP to ATP conversion step is bypassed. This ADP to ATP. So this step is bypassed, so there will be no ATP which is going to be produced in this 2,3-biphosphoglycerate. So if you see, around 10% of the glucose actually enters into RL shunt. Rest 90% will undergo normal glycolysis. This enzyme is called as 2,3-biphosphoglycerate mutase, and this is called as 2,3-biphosphoglycerate phosphatase, because it is going to remove. So this is your Rappaport looping cycle, or 2,3-biphosphoglycerate shunt. Now, important thing is, you know that in RBC, 2 ATP is being formed because RBCs undergo anaerobic glycolysis. And when this shunt happens, you realize that this step is bypassed. So per glycerate molecule, per glyceraldehyde 3-phosphate molecule, 1 ATP is lost here. So 2 ATP total. So when we minus that 2 ATP, whenever a glucose goes through an RL shunt, there is no ATP formed. And this is a very, very favorite question. Whenever glucose enters into RL shunt, there will be no ATP being formed. Yes. Is everybody clear? All of you? Excellent. Very good. All of you. So this is your 2,3-biphosphoglycerate shunt. Again, a very simple shunt, but you should remember the concept. There are two, three things you should remember: the enzyme. You should remember that it happens only in RBC. You should remember that around 10% of the glucose goes into RL shunt. And the most important thing, when a glucose enters RL shunt, no ATP is going to be produced in erythrocyte. So these are the important facts which you have to remember. Now, this brings us to the end of today's session. Reminder about the Plus subscription, the Iconic subscription, and these are the offers which are going on for the Plus as well as Iconic students. Remember, you can get a 10% off by using this discount code Dr. Abhishek 10. Okay, and if you are going to appear for NEET PG this year, make sure you pick up this 3+1 offer. If you are going for a NEET PG on FMG next year, then take this 12+2 offer, which means you pay for 12 months and get 2 months more. And if you are still a first, second, third year student, you can think of a longer duration, because then the cost really comes down to less than around 1.5K per month. Okay, this is, you can get this offers by logging on to the Unacademy app. This is my discount code. If you use this discount code, you will get a 10% off, and I'll get a credit for bringing you onto the Plus platform. So this brings us, remember to subscribe to my email newsletter so that you can get a notification whenever I go live. And thank you so much for attending this session. So this brings us to the end of all the YouTube sessions which you had to take for this month. From Monday, I will be live on Unacademy platform at the same time. So 1:30 I will be live every day, Monday to Friday on Unacademy platform. So with this, I'll end the class. Thank you so much. There have been so much nice discussion today. And thank you, Charu, Ravi, Medischool Mnemonics, Saif. So there has been some really nice discussion by all of you, especially Ravi, Charu. Thank you, Pratik, for joining in between. I think you were an undergrad student. So thank you so much, guys. Take care.